Of all the small bright objects in the night sky, there is one that particularly stands out against the morning and evening sky. It's Venus, also known as our sister world. Venus has always been a part of human study and culture, going back to the earliest civilizations. But it wasn't until the last century that we began to understand what it is truly like on the surface. We now know that Venus is a burning, toxic world and nothing like the Earth. But the two planets do share similarities, and once shared even more than that. Both planets are similar in size, mass, and composition. Both are made from the same materials and are at relatively similar distances from the Sun. So why is it that Venus is such a barren, suffocated wasteland now, while its sister planet prevailed? Venus is one of 4 rocky terrestrial planets in the inner solar system. These rocky planets formed from the remnants of the cloud that gave birth to the Sun, with leftover atoms and gas sticking together to form dust and rocks. As these rocks grew larger, they eventually became large enough to be rounded by their own gravity, turning into planetary embryos, which smashed together as they fell into position in orbit around the infant Sun. Billions of years later, 4 terrestrial worlds remained: Mercury, Venus, Earth, and lastly Mars. Of the 4 planets, Earth lies in the most ideal position around the Sun, in the so-called Goldilocks zone, where it's not too hot or too cold, allowing the planet to sustain liquid water on its surface. Venus, on the other hand, formed too close to the Sun and became a scorched world of extreme weather, with surface temperatures hot enough to melt zinc. Venus is the hottest place in the solar system, even hotter than Mercury. And like Mercury, it doesn't possess a moon or any natural satellite. It orbits just over 100 million kilometers away from the Sun, closer than Earth by about a quarter. When the planets align, Venus approaches Earth as closely as 40 million kilometers, making it practically our next-door neighbor. As it orbits, Venus rotates in the opposite direction to all the other planets in the solar system, apart from Uranus. Planets tend to orbit and rotate along the same disk and in the same direction because of the motion of the rotating cloud that collapsed to form the solar system. One thing that might counteract this resonance is a collision with another planet or planetary embryo. Such a collision might also explain how slowly Venus spins in this opposite direction. The planet is roughly the same size as Earth, but takes a full 243 Earth days to rotate just once, longer than it takes to complete a full orbit around the Sun. As such, its day is longer than its year. Venus shares many characteristics with Earth. Both planets have a thin crust, a molten mantle, and a central core. Because it is so nearby and luminous, Venus has been observed since records began. Venus is named after the Roman goddess of love and beauty, and is the only planet named after a female deity. In fact, Venus is more associated with femininity than any other planet. But not every civilization fully understood the planet when observing it. The Maya, an early Mesoamerican civilization, knew it as Chak-Ek, or Great Star, believing that Venus was actually a luminous star and not a planet. Some civilizations even went one step further and mistook the world for 2 bright stars. The reason lies in the nature of its orbit around the Sun. When Venus overtakes Earth along its orbital path, it shifts from being visible before sunrise to being visible after sunset. As such, the ancient Egyptians, Greeks, and Romans all believed Venus was actually 2 separate stars, the morning star and the evening star, which the Romans knew as Lucifer and Vesper. Not everybody made this mistake. Some early civilizations correctly recognized the morning star and evening star as a single object. The earliest known acknowledgement of Venus as a single object was made by the Sumerians, an ancient Mesopotamian civilization that existed during the Bronze Age between 4,000 and 5,000 years ago. A cylinder seal recovered from the Jemdet Nasser period, about 5,000 years ago, indicates that the Sumerians knew the object as Inanna, a Mesopotamian goddess associated with love, sex, war, politics, and justice. Another early artifact identifying Venus as a single object is the Venus tablet of Amisaduqa. a record of Venus's movements believed to have been created more than 1,500 years before the Common Era. The Babylonians knew Venus as the bright queen of the sky. In the 1600s, Galileo Galilei studied the planet and discovered its orbital phases, helping him understand that the solar system was centered around the Sun and not the Earth. But even as telescopes improved and we began to understand the planet better, we were unable to learn much more about its surface because we simply couldn't see inside. Venus is covered in a layer of highly reflective clouds made of sulfuric acid in its upper atmosphere. This makes the planet brighter than it would otherwise appear, but also completely blank and featureless. For this reason, scientists debated for centuries what could lie on the surface, imagining everything from an ocean world to a fully inhabited world like our own. But to find out, we would have to actually land on the surface and see for ourselves. Venus was the first planet we successfully flew past with a robotic spacecraft, NASA's Mariner 2 mission in 1962. Then, throughout the 1960s and 1970s, the Soviet Union pushed even closer with the Venera program. In 1967, Venera 4 entered the Venusian atmosphere and showed that the temperature was far higher than previously believed. Venera 7 became the first successful mission to land on the surface. Then, more than a decade later, Venera 13 reached the surface alive and transmitted over 2 hours of groundbreaking scientific data, along with the first colour images of Venus's alien landscape. Venera 13 revealed, once and for all, the hellish, tortured wasteland that Venus is today. With an average temperature of 462 degrees Celsius, Venus is by far the hottest place in the solar system. Its lower atmosphere, beneath the clouds, is a choking mixture of 96% carbon dioxide, with most of the remainder consisting of nitrogen. Across the planet's surface, the atmospheric pressure is 91 times greater than the pressure at Earth's surface, equivalent to the pressure found thousands of feet below sea level. As technology improved, more missions were sent to perform radar mapping of the planet. Whereas visible light collected by normal cameras cannot pass through the thick clouds of the upper atmosphere, microwave radiation can. This allowed us to obtain our first detailed surface maps. In 1990, the Magellan spacecraft entered orbit around Venus and mapped its surface in remarkable detail. It also detected extreme winds, abundant lightning, and, in 1985, a highly reflective substance in the higher reaches of the planet that is thought to be snow-like, although its composition remains unknown. Venus has over 1,000 impact craters, all of which are at least 3 kilometers wide, meaning they were formed by meteoroids at least 50 meters in diameter. On Earth, a 50-meter asteroid would be enough to wipe out a city. But on Venus, any meteor below this size wouldn't even reach the ground before being completely disintegrated during its descent. Furthermore, the vast majority of these large impact craters remain in immaculate condition, showing virtually no signs of subsequent impacts or weathering. While Venus doesn't have any known mechanism for tidal heating, a discovery made in January of this year suggests the presence of young, fresh lava flows on the surface, along with spikes in sulfur dioxide. This indicates that Venus is still a geologically active world. Much of the Venusian surface appears to have been shaped by volcanism. The planet has more than 150 volcanoes over 100 kilometers in diameter, and 80% of its surface consists of vast plains formed by ancient lava flows. What this indicates is that the planet was almost completely resurfaced around 300 million years ago. The volcanoes must have erupted on an enormous scale, covering the surface with lava that later cooled into the vast plains and highlands we see today. And like the impact craters, this landscape has remained remarkably well preserved ever since. On Earth, plate tectonics constantly reshape the crust, but Venus lacks tectonic activity. So while Earth's surface is continuously renewed every 100 million years or so, on Venus, the process appears to take closer to 500 million years. Furthermore, scientists don't believe this is a slow or gradual process driven by convection currents. Instead, they think that heat rising from the planet's core gradually builds within the mantle, making it hotter and hotter until it eventually triggers a global resurfacing event. The entire surface is swallowed up, covered by lava, and then cools and hardens once again. It then remains largely unchanged for hundreds of millions of years before the process repeats. The remainder of the planet's surface consists of two enormous highland continents. One, Ishtar Terra, lies in the north and is roughly the size of Australia. It is named after Ishtar, the Babylonian goddess of love. The other is Aphrodite Terra, named after the Greek goddess of love. It is roughly the size of South America and stretches just south of the planet's equator. Even in its hostile and extreme present-day state, Venus remains one of the most fascinating worlds in the solar system. But it hasn't always been this extreme. In fact, this toxic desert planet may once have experienced conditions remarkably similar to those on Earth. Back when the solar system was young, Venus may have been the place to be. The Sun is the giver of light within the solar system, radiating energy as heat from its surface to each of the 4 terrestrial planets. Earth sits in a fortunate position. It is just the right distance from the Sun to have sustained an atmosphere for billions of years. However, the Sun hasn't always been at the brightness and intensity we experience today. As a star ages, it burns hotter, making it brighter, and the Sun is no exception. 4 billion years ago, it was much younger and fainter, and so were its stellar emissions. At the same time, Earth was forming alongside its lost twin, Venus. Within a few million years of its formation, the Venusian surface had cooled. Unlike Mars, Venus was large enough to retain its atmosphere. Venus's early atmosphere consisted primarily of carbon dioxide and water vapor. This atmospheric layer protected and warmed the planet through the greenhouse effect. These early atmospheric gases were transparent to visible light, so, as sunlight passed through the atmosphere, it warmed the planet's surface. The surface then re-emitted that energy as infrared radiation, which was absorbed by the greenhouse baskets, preventing much of the heat from escaping back into space. Gravity kept this atmospheric layer tightly bound to the planet, like an all-encompassing blanket. This allowed primordial Venus to retain just enough heat to maintain a temperate climate with a relatively mild atmosphere. As the greenhouse effect stabilized the planet's temperature, the water vapor in the atmosphere began to condense. Clouds formed. Then the rain began. Like on Earth, it rained every day for thousands of years. Water carved streams. Streams became rivers. Rivers filled lakes. Lakes merged into vast seas. Venus became an ocean world, sustained by its temperate atmosphere and fortunate distance from the young Sun. It's almost certain that life on Earth began in the oceans, perhaps around deep-sea hydrothermal vents. These vents are powered by geological activity and release mineral-rich material from Earth's mantle. The combination of heat, water, and minerals created the conditions that eventually gave rise to the first cellular life. When we explored Mars, another planet that may once have been a water world, we also found evidence of ancient hydrothermal systems on its dried-up ocean floors. Mars may have possessed deep-sea vents and habitable oceans for a few 100 million years before it lost too much of its protective atmosphere to space. Venus, however, was larger. It may have been able to sustain its oceans for around 2 billion years. Given that Venus is geologically active today, it was likely geologically active back then as well. That means there may once have been bubbling hydrothermal vents at the bottom of its oceans, long since erased by global resurfacing events. Given Venus's remarkable similarities in size and composition to Earth, it's difficult not to wonder about the possibility of abiogenesis occurring there as well. Perhaps chemistry unfolded on the Venusian seafloor just as it did on Earth's. Perhaps Venus was once an inhabited world, just as the legends foretold. If anything did live on Venus during this period, it likely wasn't anything more complex than microbes. After all, it took several billion years for multicellular organisms to evolve on Earth, along with a series of global catastrophes and mass extinctions. Any life on Venus would have almost certainly consisted solely of single-celled organisms, such as bacteria. But even that is a fascinating possibility. With life as diverse and resilient as it is on Earth, separate windows of opportunity for habitable water worlds on both Mars and Venus along with the potentially habitable conditions of moons like Europa and Enceladus, give us hope that extraterrestrial life may be common, thriving on rocky planets and icy moons throughout our galaxy, and perhaps even beyond. So what happened to this lost oceanic kingdom? The greenhouse effect continued to maintain balance on the planet for hundreds of millions of years, but during this time, the sun was aging and evolving. As it grew older, it burned hotter and became brighter. As this happened, more heat became trapped beneath Venus's atmosphere, gradually warming the surface and slowly evaporating its oceans. At higher altitudes, the water vapor condensed and fell again as rain. But before long, the surface temperatures became so extreme that the rain boiled away before it could even reach the ground. As more water vapor accumulated in the atmosphere, it trapped even more infrared heat beneath the atmospheric layer. An irreversible runaway cycle had begun. The oceans gradually disappeared. The remaining water vapor was slowly stripped away into space by the solar wind, aided by Venus's lack of a strong magnetic field. All that remained were dry, scorched deserts, destined to be buried and reshaped by volcanism. The water world, and anything that may once have lived there, was gone. So that's the past. We know the present, but what about Venus's future? Venus's extreme conditions and close proximity to Earth make it an intriguing world to study. But maintaining a presence on the surface of such a hostile planet remains a significant scientific challenge. In 2016, NASA's Innovative Advanced Concepts (NIAC) program explored the idea of the Automaton Rover for Extreme Environments, AREE, a wind-powered, self-controlled rover designed to survive the brutal conditions of the Venusian surface for extended periods. The concept is still in the planning stage. However, there are now hopes that similar technology could also be adapted for the exploration of Mercury. But perhaps landing on the surface of Venus isn't even necessary. The planet's upper atmosphere may be a far more practical destination. While Venus is unimaginably hostile at ground level, the temperature and atmospheric pressure decrease dramatically higher up. At an altitude of around 50 kilometers, the atmospheric pressure is remarkably similar to that at Earth's surface. Sending scientific missions into the upper atmosphere may therefore offer our best opportunity yet to explore our sister world. Scientists have proposed launching aerostats, essentially giant ultralight balloons, that could remain suspended in the upper atmosphere for long periods. Such platforms could one day support floating laboratories and perhaps even crewed missions. However, that technology is still a long way from becoming reality. Even without the crushing pressure found at the surface, any balloon or aerial platform would still need to survive prolonged exposure to highly concentrated sulfuric acid. Whatever we decide to do, we unfortunately can't get too comfortable. The sun is still aging and evolving, and the next stage of its life will prove catastrophic for Venus. As the sun leaves its main sequence phase, it will rapidly expand and cool, ballooning to more than 250 times its current diameter. When that happens, Mercury and Venus will be completely engulfed by the newly formed red giant sun, and Venus's story will be over once and for all. Venus's best days are behind her. Once an illustrious ocean world, it is now a toxic sphere of rock and gas, waiting to be consumed by a dying star. Venus once possessed all the ingredients needed to be Earth-like, but ultimately it was simply too close to the sun to sustain those conditions. It's both fascinating and unsettling to think that being just 25% farther from the sun has made all the difference for Earth in the long run. Earth truly is the solar system's greatest success story, but Venus's story is just as fascinating, and perhaps far more intertwined with our own than we yet realize. It's difficult to imagine Venus as anything other than the hostile world we see today. But who knows what events may have unfolded during those 2 billion years when Venus was Earth's true twin?